Good day, everyone. My name is Jerlyn Soliguen of ECE 3A. So for today, I'm going to present to you my performance task number 4 in ECE 23 Communication 2. So what are the topics to be discussed? So first, the topics to be discussed are pulse code modulation, other variants of PCM, and adaptive delta modulation. So what is pulse code modulation? It is a digital scheme for transmitting analog data. It converts analog signal into digital form. The transmitter section of a pulse code modulator circuit consists of sampling, quantizing, and encoding, which are performed in analog to digital converter section. The low pass filter prior to sample prevents aliasing of the message signal. Pulse code modulation is a method that is used to convert an analog signal into a digital signal so that a modified analog signal can be transmitted through the digital communication network. PCM is in binary form, so there will be only two possible states, the high and the low, which is 0 and 1. In pulse code modulation, the intelligence signal converts the carrier into a series of constant amplitude pulses spaced in such a manner that the desired intelligence is contained in coded form. The basics operation in the receiver section are regeneration of impaired signals, decoding, and reconstruction of the quantized pulse rate. Following is the block diagram of PCM, which represents the basic elements of both transmitter and the receiver section. So you can see here the analog message signal, LPF, sampler, quantizer, encoder. So the PCM output given to the channel section wherein there is the regenerative repeater. And then when you go to the channel output, it will go to the receiver section, the regeneration circuit, decoder, reconstruction filter, and destination. So what are the other variants of PCM? So the other variants of PCM are differential pulse code modulation, delta modulation, adaptive differential pulse code modulation, adaptive delta modulation, and the delta sigma modulation. But here today in my presentation, let's talk about about the adaptive delta modulation. So what is ADM? This modulation is the refined form of delta modulation. This method was introduced to solve the granular noise and the slope overload error caused during the delta modulation. This modulation method is similar to delta modulation except that the step size is variable according to the input signal in adaptive delta modulation, whereas it is a fixed value in delta modulation. In digital modulation, there is a problem in determining the step size, which may have an influence on the quality of the wave which is produced as output. We require a larger step size in the steep slope of the modulated signal, and a small step size is required when the message has a small slope. This kind of detail is ignored in delta modulation techniques, so we need to have control over the step size according to our requirements so that we are able to obtain the sample output in the required fashion. So what is the block diagram of ABM? So as you can see here, this is the block diagram of ADM. So it includes the ADM transmitter and receiver. The transmitter has a summer, a quantizer, a delay circuit, and a logic circuit. Here, the step size is kept fixed between some predefined maximum and minimum values. The upper limit is used to control the slopes, overload distortion, and the lower limit is used to control the granular noise. The step size increase or decrease based on a certain set of rules. So first, the logic for step size control, it will go to the 1-bit quantizer. You have the delay, the stigma. You can see the input and the output in here. The ADM receiver has two parts. The first part is used to produce the step size from the incoming bits. The bits are then applied to the second part of the receiver, which contain an accumulator. The function of the accumulator is to build up the staircase waveform. The signal is then passed through a low pass filter, which is used to smoothen the staircase waveform and reconstruct the original signal. As you can see here, this is the the ADM receiver. You can see here is the input, the logic for step size control, the late TS, accumulator, low pass filter, and the output. So, what is the modulation theory? In adaptive delta modulation, the step size in the staircase signal is not fixed and changes depending upon the input signal. Here first, the difference between the present sample value and the previous approximation is calculated. This error is quantized if the present sample is smaller than the previous approximation. Quantized value is high or else it is low. The output of 1-bit quantizer is given to the logic step size control circuit where the step size is decided. So you can see here is the x of t as the input signal, and x sub q of t is the staircase waveform with the variable step size. So at the logic step size control circuit, the output is decided based on the quantizer output. If the quantizer output is high, then the step size is double for the next sample. If the quantizer output is low, the step size is reduced by one step for the next sample. The step size is determined by the amplifier gain. This is because the step size is proportional to the amplifier gain. So we can say the ADM is basically a type of delta modulation. It is mainly used to overcome slope overload, distortion, and general noises which occurs in delta modulation. Here is the step size of the quantifier varies according to time. So, what is the difference between delta modulation and adaptive delta modulation? The difference between the two include the following. First is in the delta modulation, the step size cannot be varied. It remains fixed for the entire signal. However, in the case of ADM, the step size can be varied according to variation of the signal. Next is the in delta modulation, slope overload, distortion, and general noise can be present, but in ADM, quantization noise is present. The other types of error are mainly avoided. Next is then this modulation utilizes the bandwidth a lot more efficiently as compared to that of delta modulation. So lastly, it has a wider dynamic range than delta modulation. So let's talk more about ADM. So what are the advantages of adaptive delta modulation or ADM? So these are the advantage that you can see here in the advantage box. First is that this modulation can be used to reduce the slope error which is present in delta modulation. This can be used to remove the granular noises from the signal. It has a improved signal to noise ratio as compared to that of delta modulation. ADM has a low pass filter that can be used to remove the quantization noise. It has a higher dynamic range as compared to delta modulation. There is no need for the error detection in the case of adaptive delta modulation. So you can see here in the other box is the application of ADM. So this includes the following. First is it is effectively used in audio communication. Next is it can be used in systems that require improved voice quality. It is used to voice coding. It is used in television signal transmission. The securient line of Motorola uses in 12K bit per sec adaptive delta modulation. It is used for NASA and many more. So this is the end. Thank you for listening and bye.